and welcome to this workshop on building intelligent user interfaces with MediaPipe solutions. My name is An Patel, and I'm a software engineer at ShareFile in Raleigh, North Carolina. I'll be your speaker and host for today. Here's the agenda. So we'll begin with the motivation behind why this workshop came to be, and we'll discuss what exactly we are building by looking at first just a rudimentary design or a blueprint of our app, and then we'll look at MediaPipe solutions as a whole. As a part of it, we'll see some demos of what MediaPipe solutions have to offer. Next, we will dive deeper into the mechanics of the text embedder model that's offered by MediaPipe Solutions. We will look at what exactly the universal sentence encoder model does and at a high level, and then explore the concept of cosine similarity, which is what we'll be utilizing for the app that we are building. And then we'll go over the source code of the smart to-do list app that we're going to be building. We'll see how it was scaffolded, how you can add that smart intelligence bit into it, how you can configure MediaPipe text solution and the sentence encoder model into the React application, and utilize cosine similarity to build out that feature. And finally, we'll test out the app, and there are some performance and AI safety caveats, and it's actually probably going to be like an open discussion. So yeah, we'll chat about it after we look at what we have built. Without further ado, let's go ahead and get started. First, about the motivation behind this app. I was looking at this presentation by Dan Saffer at this conference that happens in Raleigh, North Carolina. It's called UX UAll, and it's a UX conference. And I found this slide very interesting, and it talks about, or rather argues that the real kind of sweet spot for integrating AI into your business applications is, as Dan argued, really at low risk, low or moderate risk, and moderate accuracy, rather than what companies usually go for, which is trying to build very technically challenging and models that demand high accuracy and pose a huge risk when they go wrong. So instead of that, Dan argues is that you could build features into small places in your app to make your customer that much more successful and deliver value by grabbing these sort of low-hanging fruits. And so this is one attempt to do that, and which is, let's build a simple app and integrate an AI model into it, which is not necessarily supposed to be a very accurate or highly specifically trained model for this particular task, but just something that enhances the user experience a bit, even in a simple app like a to-do list. And so this is the basic outline of the app that we're going to be looking at, that how it was built. And it's really simple. So it has a text box where you can type a to-do, and it has a button that lets you create that to-do or a task, and you can add categories and put these tasks in whatever category you want. And then there's a magic button on the bottom right, which when you tap, it will reorganize all the tasks into their respective bins. So it's really an assistive feature that helps the user organize their tasks better. And these are the things we used for building this application. So it uses React, which is a JavaScript framework for building user interfaces, and uses Material UI, which is a component library built. It's Material UI is available for a lot of different platforms, but there's also a library that gives you Google-like material components for React. So we use that for that material look and feel. And finally, it uses MediaPipe solutions for that small magic feature. So let's take a look actually at the app itself. And for this, actually, let me share a link to the slides as well, so anyone can follow along and click on the link as well. And I'll also copy and paste both the app demo and the GitHub link onto the chat. So just give me a second here. So just pasted the app demo link in the chat, and this is the GitHub link. Let me get that next. Okay. So yeah, if you open up the app demo link, you will see that. Let's see if I can open it and share the tab. Okay. Hopefully you can see this. And I've actually created a few categories already. I'll just delete them. Okay. So what the app lets you do is it just lets you create a few tasks. Like, let's say you were someone in school and you had like math homework, which is one task, and then you had science homework, and you also needed to buy some groceries. And let's say we just had these three tasks, and you had these categories: school and shopping. And now you want to bin these tasks in the appropriate buckets. What you can do is simply tap this Smart Reorganize Tasks button, which should bin these tasks automatically into these appropriate categories. And as you can see, it kind of makes use of the semantics or the meaning of whatever task you are writing, and matches it with the category and puts it into that category, the best match. Basically, it tries to find the best match and then puts it into that bin. So that's the crux of the app that we are trying to build. It's really simple. It has a few interactable components, and it lets you update category manually as well if you don't like what the auto categorizer did for you. But this is the app that are going to be looking at. So going back at our slides. So how was this implemented? That auto categorization feature was built using MediaPipe solutions. And now we'll go over what MediaPipe Solutions really is and how you can make use of it. So MediaPipe Solutions is a framework by Google. It's open source. It comprises of libraries, tools, and docs that help you deploy and customize your AI or machine learning models quickly. So you don't need to spend a lot of time building models from scratch and then training them to make use of them for some very common tasks in machine learning. Like as the photos show here, one of the examples is pose detection. They have really good vision models as well. So it's the model that we are using today is one of the text models, but they also have on offer, and it's all free. They also have on offer vision models like this one that does pose detection, this one that does object detection, and this is an audio model that they are showing here in this image, which detects what instrument it's playing. And this is a text model that gives you sentiment score, whether something that's written is positive or negative. So there's a lot of different tasks that were identified by folks at Google, and they created different solutions for them. And they're all available at this link. Actually, we're going to look at a few demos of these now. Um, Before going into the demos, here is an overview of MediaPipe solutions APIs. So it's basically split into two chunks. One is MediaPipe task APIs. These are the libraries that you import into your application to run models that do different kinds of inference. So this would be, for example, a model that if you have a model that looks at an image of a hand like shown here and figures out the gesture that the hand is making, uh, you would want to deploy that on different platforms. And MediaPipe task APIs are available for Android, iOS, web, and Python. So you can also run it on the back end if you wish to, but it's a multi-platform solution for a lot of machine learning tasks. And similarly, MediaPipe Model Maker is also a set of libraries that serve a different purpose. So going back one slide, as you can see, MediaPipe Solutions is a bunch of libraries, tools, and documentation that lets you deploy and customize your AI ML models quickly. So the deploy part is taken care of by MediaPipe tasks, and the customization part is taken care of by MediaPipe model maker libraries. And it's actually probably just one library for Python. But yeah, it lets you customize a model, customize a solution that they already have by feeding your own data to it to kind of fine tune it and make it better for your particular task. Um, so that's a brief overview of these two um, APIs that they have to offer. As it says, these are all low code APIs. So there are very small snippets of code that you end up writing, and that just does everything for you. As the end product of these model maker APIs, you get a model binary, which is just a file that you can reuse across different platforms like Android, iOS, web, or even Python on the back end um, with MediaPipe tasks. So these two go hand in hand, and today we'll be focusing on MediaPipe tasks in particular, and specifically their text tasks API for the web, since we are looking at how we build a React app. So before going into the app's implementation and the model that we have used in this app, let's look at some demos of what all different solutions, MediaPipe Solutions has to offer. So I'll open this link and share this tab instead. Okay. So as you can see, there are quite a few tasks that they have on offer. And the most number of tasks are in the vision category. And they have like 3 tasks on the text category and one which is audio classification in the audio category. We'll look at a few vision tasks, like object detection. It kind of detects objects. So if I pick this image, you can see that it gets a pretty good gives you a pretty good overview of what's in the image. And you can set different parameters. So if you put this slider to 10, it will find as many entities as it can, and it all runs on the client side. It's currently running on my machine, and you can also set whether you want to use the CPU or your GPU for inference. If I pick a CPU, it's gonna use my CPU. And it also lets you play around with different models that they already have available for you to pick. Plus, you can upload your custom model if you trained one using MediaPipe model maker that we just talked about. So yeah, that's the object detection model. There's also image classification that looks at the image and tries to answer what that image is about. Then there's image segmentation, which lets you click on parts of an image. Well, it's not really. Oh, that's the interactive segmentation one. This one kind of tries to segment based on presets. Like this model is set to segment out selfies. So if I had a human image, would get a selfie and highlight that. Currently, it seems to be thinking that this divider in between is a selfie, but it's pretty accurate if you give it like a photo of some person. And interactive segmentation is actually really cool. So if you click on something, it figures out what you are trying to select, and it gives you a mask, a set of pixels that it thinks are a part of the entity that you are trying to select. Um, and it's pretty useful for things like image editing. Say you are creating some image editor as a web application, or something like that. Or maybe you are offering it as a kind of an enhancement to some existing app, that like a social media app or something. Um, so yeah, that's interactive segmentation. Then they have gesture recognition, which takes, let me see if I can find a file. Yeah, so it picks up whatever gesture is being made on the. I see a comment. So basically, this thing picks up whatever gesture is being made on the image, and it spits it out. But there's a question in the chat about, do you need a Google Cloud account for using MediaPipe Studio? No, not really. You can open up this link from the slides that I shared, or let me share this link actually in the chat if I can. Copy this and paste it. Okay. So it's actually free, and anyone can open this link and try to play with it. And there's a lot of cool stuff. So after gesture recognition, they have hand landmark detection, where it's pretty similar to the gesture recognizer, but actually it's it's one step short of classifying what the hand landmarks are conveying. It just gives you a set of hand landmarks. So it gives you this the points that are shown in red in the image as output. In fact, I think the hand recognizer, so hand gesture recognizer is probably built on top of the hand landmark detection model. So you get the landmarks, and then you run some kind of a classifier on top of it to uh, get the inference about what kind of gesture it is. Um, then there's image embedding, and this is really useful when you want to compare two different images and make some kind of inference out of that. So if you upload two different images, it will try to say how similar or different these are, and it will give you a similarity value. We'll discuss more about this concept of cosine similarity in the slides to come, but just know that it's there, it's on offer. Then there are some models for face stylization. Let's see if I don't have a good image for a face right now. Um, So we'll skip this one. There's one for face detection. It just captures faces. It actually should have an example here. And similarly for face landmark detection and pose landmark detection. But the model that we are going to be using today is the text embedding model. And what that does is it converts a piece of text of any length. So, like we did for our to-do app example, you can type like math homework or something, and then it's gonna create a vector, which is just a bunch of numbers, a sequence of numbers um, that is in a space that kind of encapsulates the model's understanding of the world, and the vector itself kind of tries to encapsulate the meaning of whatever text you um, entered. So, for example, let's try entering math homework and shopping and see how similar they are. So it gives us a similarity value of 0.88. By itself, it doesn't really convey much. But now, if we compare this, math versus shopping gave us 0.88. Now, if I put here something like school, it should be more than 0.88 ideally, and it is. Although albeit by just a little bit, it still carries more meaning and is more similar to math homework, and so you get a higher similarity value. And that's basically what is powering the app that we just saw, the to-do list app. Yeah, that's an example of how simple it is to use MediaPipe Studio to kind of play with these different models and figure out if there's something that you can use in your app, and then we can actually use it in our app. So let's start doing that. Before we do that, we need to understand at a high level what really is happening under the hood. So you just saw that by plugging in the text and passing it through the universal sentence encoder model, you get back a vector, which is just a list of numbers that encapsulates the meaning behind that piece of text that you passed through the model. And there's detailed info around this model, but just know that it's a deep neural network. It's developed by Google. They trained it, and so it's really good at giving you vectors that encapsulate the meaning of the text that you passed in. So once you have such vectors, you can run this thing called cosine similarity over it. And cosine similarity is a measure of how close two vectors are in space. And if we go back to this tab here, you'll see that this is a really long list of numbers. The model that we are using here is the universal sentence encoder. And what it does is it takes a piece of text of any length and gives you a 512 dimensional vector. If it was in 2 dimensions, the vector would look something like this on a flat plane. You could actually visualize it. If it's in 3 dimensions, humans can still imagine it, but over 3 dimensions, it's beyond human capacity to actually visualize vectors. So, but still at a high level, what's happening here with those 512 dimensional vectors is you're taking vector A, taking vector B, so you're taking two vectors, and then you're computing the cosine of the angle between those two vectors. And that gives you a measure of how directionally close those vectors are in space. So the cosine function, it returns -1 if the vectors are completely opposite, and it returns 1 if they are aligned completely. So depending on the angle, the cosine similarity will change. For example, this cosine similarity of the angle you are seeing right now would be more than the cosine similarity for this angle, because the angle is over 90 degrees. So it would be it would probably be negative now. So yeah, that's a brief overview of the concept of cosine similarity and the universal sentence encoder model that MediaPipe uses. MediaPipe Solutions has on offer for doing text embedding. So this process of converting text into a bunch of numbers is called uh, generating generation of text embedding, or just getting embedding getting embeddings for text. So that's the task name, text embedding, and we're going to be using this solution in the app. So let's actually start looking at the source code of the application and see how the app was built. I'll shift over to Visual Studio Code, and I'll wait here for a moment for any questions before moving ahead into actual source code. Okay, cool. Right. So I'll also wait for people to actually clone the repository if you are doing it. Let me paste the repository link again. If you open this link, you will find all of the source code for this app. Let me see if I can share this tab. Okay. So this is the GitHub repository for the app. And if you click this green button that says code, you should be able to copy this snippet, or even download the whole thing as a zip file and then unzip it. And I'll wait for a couple minutes here so that anyone who's trying to follow along gets to download the repository, and then you can actually fire up the app and try it out on your local machine. So yeah, if you are following along, if you are cloning it, just type cloning or something in the chat so I know if I need to wait or not, and then we can dive into the source code. Okay. How do you save the chat?
Yes, the reason why is I want to get the collection of LinkedIn names, but also I tried looking around my screen and I just couldn't find a way of doing it.
Yeah, I think the best way would probably be to copy and paste the whole thing. I was able to drag and select the entire chat.
Oh, good idea. Thank you.
But actually, let me see if as an organizer, I might have access to the event chat. Maybe they don't persist it, but I'll just check it out while everyone's cloning it.
Oh, just to let you know one very important thing, I am a presenter, and I just want to let you know that I shouldn't be.
Oh, that's interesting. Oh, I see everyone is a presenter here. I think by default, the first 50 participants are presenters. So they can always unmute themselves and like turn on their camera and talk. It's, I think, like a default setting on this event platform. So Gopi is asking if we are on the master branch. Yep, we are on the master branch. I was thinking of creating it in an exercise-like fashion, so I started on the route of creating like an exercise branch and deleting a bunch of code. But then I thought I can just go over each commit and show how it was built from the ground up, which would be a better use of everyone's time rather than everyone watching me typing and making typos and wasting everyone's time. So yeah, there's the whole commit history, which we're gonna look at next. But yeah, before that, like, yeah, I see people. Some of them are done cloning it. I'll just wait for the others who said cloning to make sure everyone got the code, and then okay. I think there's just a couple more people, and then we can move to the code. Yeah, in the meantime, if you have already cloned the repository, if you look at the README file, or if you scroll down on the GitHub page, you will find some instructions here, and that will show you how to get the app running. And it should just be, if you have Node.js installed, it should just be doing npm install followed by npm run start in your terminal after opening the project in Visual Studio Code. And then you will be able to see the app running. If you're having trouble with it, just let me know. Okay, looks like most people are done. Okay, so yeah, now we can actually take a look at how the app was built. And let me shift back to the slides. So the first step to building this app was to scaffold the basic functionality of the to-do app. So before all of the magic AI stuff, there's really not much to the magic AI stuff, really. It's most of the code is really just the functionality that does the to-do list and the categories. So for that, we used create React app, which is a script that you can run to initialize a React.JS project, and then I installed TypeScript, which lets you write JavaScript but in a type-safe manner. And then I installed a couple of dependencies to get Material UI for React. So to get those Material UI components that look and feel like you are on an Android phone, and a few other libraries like UUID. This is not a comprehensive list, actually. Let me shift to the code commits. That's actually a better, yeah. So if I zoom in, this is what the structure of the code looks like when you run npx create React app. It creates like a boilerplate application for you with a dummy page and its source code is in app.js. So it creates everything in JavaScript world. There was a TypeScript template, but you can separately just install TypeScript as a dependency, and it just works right out the box. And you just need to rename the .js file to a .tsx file, and then it becomes TypeScript. So yeah, this is just the scaffolded app. If you look at the package.json, if you're new to Node and npm projects, this is a file that where you describe or define what dependencies your application has, and it here we have just initialized or scaffolded the React application. And once this was scaffolded, the next thing I did was, um, let's go back to our commits. And yeah. So the next thing was really scaffolding the app, and uh, I dumped a lot of the code into the app file. Um, let's see. Actually, it's this part is just adding material UI. Yeah. So for adding material UI, you need to add a few other dependencies like this Roboto font, which is used by material, and Emotion, which is a styling library that lets you do um, inline styles and styled components. So you can create components in React. Components are like custom named. uh, if you are familiar with HTML, you have HTML components like div, but you can also create your own uh, HTML-esque. They call it JSX, JavaScript extended, and you can create these custom components to kind of encapsulate your code better and organize your code better. So this is just adding material UI to the app and doing a hello world. I added like a hello world button here in the app.tsx file. So till this point, we have just added some dependencies and scaffolded the application, not really added any functionality. The next part, I think this commit adds all of the to-do app functionality, but not the AI functionality. So if I can make this, let's see if I can open the whole file. View file. Okay. So this file here, as you can see, it has a lot of code in app.tsx now. Before it was just a hello world button. Now there's a lot of code in it. And more recently, I added a few comments. It's just this same file, but I've moved a few components out of this app.tsx to make it less bulky. So I'll share my screen to show the latest. If you cloned the repository, you would also have the latest code with all the comments in it, and it won't look like what's on my screen right now. So let me open the code with all the comments in it so we can go over that. Let's see, share screen, and I'll share my VS Code window. Okay, so we also used this thing called React Query, which is handy for doing things like doing things which are asynchronous operations. So here we wanted to run a function as soon as the app loads, and I use this handy function. It's called a hook in React world, and you can run something that needs to happen as soon as the app starts. And then this is where we are creating some variables to store the state of our application. So by the name, you can guess that this variable to-dos is going to hold all the tasks or the to-dos that the user creates and adds. By default, it already has a task in it. as you can see here, it has a task with some random ID. V4, this function, it generates a random ID. It's just wherever you see V4, just imagine it's just generating a random ID. And the content is example task. And if you run the app and open the uncategorized section by default, if I can quickly screen share that app again. Yeah, if I refresh, it always has an example task. And that's where this is coming from. So going back to the code. So that's the example task. And this use state function, when you call it, you can specify an initial state. So that's where we are providing that example task. And then by default, we need a category, which is the unorganized category where everything falls into by default. So whenever you add a new task, it goes into this uncategorized category. And then we have this array. Actually, it's a 2D array, which is organized in this way. So each, for example, it would have the first one would be example task, and it's a list of lists. So for each category, it holds a list of tasks, and it's by the category's index. So this list of categories is containing a single category when the app starts, and its index is 0. So this tasks by category 2D array, its first element is going to be a list of tasks, which would be the unorganized tasks. And we are just computing it on every time the component renders. So anytime you do an update to the application, the whole this this entire piece of code runs again. This entire app function runs every single time. And React has some optimizations in place which avoids repeated computations, and it just does only the computation that it needs to at every render. So you don't see it happening, but in reality, when you update, when you do anything with the application, you make a change to its state, it will run the whole function again. And so this tasks by category, as you can see, it's actually a computed value from the to-dos and the categories lists, and it's building this out. And the reason we are building it out is we need it in this format to show it, to render it on the screen down below. This part after the return statement is it defines the actual rendering of the contents of the state and the data that you are preparing over here. And then there are a bunch of, there are a couple more state values. So this state value for to do, it just holds the current task being created. And React, when you call this use state function, it gives you two things. It gives you the value of that state variable, and it also gives you a function that lets you update that value when something happens. And then you can call that function in different places in your code to cause that update to happen. And so that's how we have wired up all of these different updates and adders, all of these different handlers basically to do these different things. And this is also another little bit of state that you need to encapsulate whether the dialog box to add your category should be shown or not. So it's a Boolean value, and it starts off as false. So the category dialog box doesn't show up. The category dialog box is this dialog box, by the way. Let me see if I can show that. So when you click add category, it pops up a dialog box, and this is the category dialog box. So that's the dialog box. And these are all the different methods that just handle and adding and updating and deleting these tasks, and adding, updating, and deleting the categories. So it's all just management. The real magic happens in this part of the code, where we wait for the MediaPipe model to be loaded, and then we wait. Then we actually go over each task and put it in the correct or best matching bin. And before we go into this source code, we want to switch back to the presentation, and let's see if I can stop sharing and share. Okay. So we talked about the universal sentence encoder model and cosine similarity, and we saw MediaPipe solutions for text, um, and we saw how the app was scaffolded for all of the to-do list functionality. And now we're going to talk a bit about that magic reorganize feature and how it's all wired up. So now you know that in our app, there are variables in which you have a bunch of tasks, and you also have a variable that holds your entire list of categories. So just a second. I think I see some messages in the chat. Is there a link to go when replaying this course? There is a link for a video. Yep. We'll be posting this to YouTube, so you'll get a link to a video. And someone pasted 258 packages are looking for funding. There's 8 vulnerabilities. That's all fine. It's because it might be using React. I don't know. It's probably React 7. No, it's React 18. So maybe it's some other small dependency that's showing vulnerabilities. But yeah, that shouldn't be an issue. You should still be able to run your app. Yeah. Okay. So yeah, moving back to the magic reorganize feature. It's really simple. We take the list of tasks and we get an embedded vector for each task. We do that same thing for each category. So we get the embedded vectors for each category. And then we get sort of a similarity matrix, and then find out which category has the highest cosine similarity for each task and put that task in that category. So let's see if I can move a slide. Okay, so this is an example of a similarity matrix for tasks versus categories. So on the y-axis, so on the left side, you will see school and shopping. These are the two assumed bins or categories. And this below is these three: math homework, science homework, and buy milk are your three tasks that you're trying to auto-categorize. And the heat map, this chart, would be more red in places where the cosine similarity is higher. So for buy milk, you will see that the cosine similarity value is higher for shopping versus school. And inversely, for math homework and science homework, you can clearly see that it's way more red, or there's the cosine similarity is much higher than it is the case for shopping with these two tasks. And that's how you can auto categorize. So buy milk will fall into the shopping bin because it's more red there, and math homework and science homework will fall into the school bin. It's more red over there. And this is a snippet of code that does that. So I got these vectors for each string from MediaPipe Studio. So from here, so by entering things like math homework, you get this entire a vector, and I've just dumped these. You could actually use their MediaPipe solution USE model for Python and get these vectors by writing some code. But this was just to show the similarity matrix. So it's a quick and dirty trick. Just copy pasted the vectors and calculating some calculating this similarity matrix. And you can see it. And that's the one I've put in the in the in the slides here. So yeah, it's just computing those similarities and getting them and using them. So here's how now you have a basic overview of the whole process, but how do you integrate MediaPipe into your application, into your React app? Uh, we'll look at the official docs for that. So they have these guides for each different platform. So if you look at these tasks on the left, if you follow the link from the slides, and the slide have been shared in the chat as well, you'll be able to see all of these different guides for each platform. So turns out text embedding is not offered for iOS, but it's there for Android, web, and Python. And for web, they have provided the whole process down here. There are a few things that you would do differently because you are using React, but most of it is the same. So you need to install the dependency, the text tasks MediaPipe dependency from npm, and then you can skip over to this part where you actually load the WebAssembly files. Um, the WebAssembly files are a bunch of files that form the low-level code base for this solution. You don't really need to know what they are doing. You just need to import these files for MediaPipe to function correctly. And you need to then create your text embedding model. And they have this class text embedder that you can import from the library that you installed. So switching over to the source code, let's actually see how that was imported. So we have this file, MediaPipe TS, and we have just imported a couple of classes from this tasks text library, and we have tried to initialize the model object. So to do that, it's really simple. You use the name of the model that you're trying to use from the solutions. We are trying to use the text embedder solution, and then you provide the WASM files, so WebAssembly files, and finally you specify any options. In this base options object, you need to specify the path of your model asset. So the universal sentence encoder model is, as mentioned before, a deep neural network, and it has a lot of parameters. And if you click on the link from this source code, it would actually download to your computer, and it's I believe it's like a 20 megabyte file. Let's see if I can actually see. Oh, it's actually smaller than that. It's a 5 megabyte file, so not huge. The reason we well, no, the model itself is gonna have all the parameters, but then you can use this option called quantize, which improves your performance. So what quantize does is it reduces the number of bits that are used to represent each parameter in the model that's loaded into memory. So this file contains parameters which might be, say, 16-bit. But when you do quantize, it reduces the number of bits it uses for each parameter, and so your model runs faster because it has less bits to crunch, and so your performance improves, but usually at the cost of accuracy, because the model loses a bit of information when you do that. So this is how you initialize the text embedder. Once you have the text embedder object initialized, you can then use it to compute the cosine similarity. It's really simple. You just call a method called embed over this object. And this is all documented in the guide. And it's just uh, going through the motions after that. So you get the embedding result and get the actual vector. So it's at this location, and the embedding vector for the second piece of text is at this location. And then you compute the similarity using a helper function that they also provide, the text embedder class. And it's just cosine similarity, and you pass these two vectors and it returns the cosine similarity. You get that back, and this is a function that we call in our app tsx here. So this function, handle smart reorganize, it gets called when the magic button is clicked. So when the magic button is clicked, handle smart reorganize gets called and it starts executing. First, it checks if MediaPipe was loaded properly. So if there's an error loading MediaPipe, then it's gonna spit that out in console, in the browser's console. And if it's loading or there is an error, we won't do any processing or that magic categorization. But if everything goes well, it would get to line 76 and execute this rest of the code, and it will categorize each of the tasks into the best matching category. The way it does that is it goes over each task and it initializes this best match object, and it then goes over each category for each task and finds out and keeps updating this best match object. And once you have iterated over all the categories, the best match object will be the best matching category. And then you just use that category ID over here and set that and update your to-dos. So this is how we are basically building a new list of tasks. The task object is an ID, content, and the category ID, which is just the index of the category. And so you're just building this new array, and you're setting the to-dos array to this new array that you just built. And that just essentially means that your to-dos will now be in the new categories, whatever was assigned here on the best match. And there you have it. That's how the smart reorganize works. And here it's a sneaky line. Here's where it actually gets the similarity value. So it loops over each category, gets the similarity value, compares it with the current best one, and if it's better than the current best one, it reassigns it to itself. So it updates the best match category ID. So yeah, that's the functionality in a nutshell. If you do npm, so if you do npm run start, it should just kick off your app and it should let you try it out. And you can also, of course, try it out at the link that was shared. Let's see. Let's now try to play with it a bit. But before that, are there any questions, or if you want to dive deeper into something, just let me know. Okay, so yeah, let's now take this app for a test drive. Let me stop sharing and share this other screen. Okay, so yeah, let's type in a few tasks. Does anybody want to suggest something to type? I always keep typing homework, and I don't know. I've just tried one category till now. I haven't tried it for
Yeah.
many more.
What
So,
about games?
what games?
Like board games, video games,
Oh
you know,
yeah,
something like that.
let's try that out. So let's do chess and I don't know, Monopoly. Let's do Mario, and let's add like video games, board games, um, and then let's do, I don't know, Zelda. What else do we have? There's let's do some card game, poker. Okay, delete this. So it should probably move the classic board games into board games. Poker is, there's also poker video games, but there's also poker that it could still, maybe it classifies it still as a board game because it's something you play in person as well. Let's see what it does, what it comes up with. Okay, so looks like it brought everything except Zelda into board games. So yeah, there's some inaccuracy that these models will always have, but it tries to, let's see if we can do something. Counter Strike is another example of a video game. Let's see if it classifies that as a video game. Yep, it does. um, let's see what else can we do. Gopi mentions, why don't you see the categories on the app? It's because you need to add a category to be able to see it. So if you click add category, it will open this pop-up, and if you type in something and type enter, it should create that for you, or you can click the done button and it does the same thing. Let's see what it does for Super Mario. Yeah, somebody typed that in the chat. Yep. Let's see if it classifies this as a video game. Yep, it does. The other thing to note is this universal sentence encoder is really suited to sentences, so greater than one word. But they can still give you, they still give you a vector for any piece of text you pass in, and it will convey the meaning. The vector will still convey its meaning, but it's meant ideally for short sentences and short pieces of text, no more than, I would say, like one or two sentences at max. But yeah, it gives you a vector, and then you can use it to run cosine similarity and do this kind of stuff. And it all happens on the user interface side. So one benefit to doing this on the UI side is that uh, if there are apps that have any privacy concerns, then you can still implement AI into that app using UI side model with MediaPipe solutions, which is what this thing is doing. It downloads the model file and everything, and it runs the model on the end user's machine, using the MediaPipe tasks API. So it takes care of all that for you. Does it support multi-language? So the model itself, I think it might support multi-language, but I'm not sure. I'll have to check that. Let's see. Might just be English. Um, but you could change the model and customize it to make it work with some other language or locale. And you can even train your own model and give it your TF Lite file. So if I move over to the source code, let's see. So the only thing it needs is a TF Lite file with the universal sentence encoder parameters, and it will just take it up. So if you retrain the model and change its parameters based on your data, it would it should technically support other languages, but probably it won't do a good job out of the box because it's trained on English data. Yeah, that's one challenge with these most of these natural language. um, it's TF Lite. Yes, TF Lite is TensorFlow Lite, and that's the underlying. It's actually a TensorFlow Lite model that they are running under the hood, but they try to abstract it out so that you don't need to even think about that when trying to incorporate these features. Um, but yeah, you can change this up, and using MediaPipe model maker, they have guides. Unfortunately, they don't have a guide specifically for MediaPipe text embeddings, but if I can show the guide for, let's see. So, for example, for text classification, they show you how you can use the model maker APIs, which are for customizing models, to actually customize a model. And it's dead simple. So you don't need to go into the depths of actually working with the underlying models architecture, the underlying neural networks architecture. You really just need to provide it with the training scheme. So how much you want to train it for, what is your batch size, so how many examples per epoch you need to cover, that's the batch size, and learning rate and stuff like that, but not really going into the nitty-gritties of the layers of your model. You just provide the data right here. So it just creates the model for you. You get the model file, and there it is. So as they say here, you can download the TF Lite model. So it's just a few lines. As you can see, it starts here and ends over here, and it's that simple. You can customize a classifier model, which is a slightly different task. So classifier will do things like it can classify between 1 star and 5 stars. So this model's output will probably just be like 0, 1, 2, 3, and 4. So it will just output one of these 5 integers based on whatever text was passed in. um, but yeah, you can customize it in that way. So if you wanted to teach it that poker is a video game, what needs to be done? I think you would need to create or update the text embedding model, but it seems like it doesn't. MediaPipe Solutions doesn't yet have customization out of the box for these models. So you might have to. One option is to turn off the quantization. So quantization is it reduces. So as it says, instead of a large number of bits, it just uses 8 bits, which is 1 byte for each parameter in the neural network. That shrinks the size of the model that's loaded in memory, but it also affects your model's accuracy. So one option is to try turning it off. In fact, let's see if anything changes if we turn quantization off, or if things blow up. Let's see. Okay, so I turned quantization off. So it was just that one flag in our source code that said quantize true. I set it to false. And let's try doing the same thing now. Mario and let's say video games. And then let's add the board games. And let's see if it classifies that better now. Nope. It still wants Mario to go in a board game. Looks like it grew up playing a board game Mario. Okay, that's pretty much it. Yeah, the other option. Well, let me open this again. So L2 normalization is it also tries to, so when your model is overfitting, you can turn this on to make it less overfitted to your data and make it more accepting of different inputs. Um, oh, Charles says there's also a Mario board game. So it was probably trained on a Mario board game, and then it thinks that Mario is a board game. Are there plans to have MediaPipe work with other TF models, like the ones found on TF Hub or Kaggle? I think MediaPipe itself is a larger framework, but as part of this workshop, the main focus was just the solutions, which are out of the box APIs with little code that you need to write. MediaPipe itself is actually bigger. So if you click on the framework tab, it tells you about MediaPipe as a framework, and it is a framework that lets you build on-device ML pipelines. So you can go very deep into the weeds of machine learning, building these ML models using low-level code. As if you might remember, we had to download some WebAssembly files, which are the backbone of that MediaPipe text solution. All of that is abstracted out by MediaPipe solutions. But you could build a cross-platform machine learning model using MediaPipe, and then use it on Android, iOS, others using MediaPipe. So if you have defined your model with MediaPipe, then you can really take it to any framework, so Android, iOS, and others. Yeah. Okay. Yeah, that was almost it. The last part is the caveats and some improvements. So there are, of course, a lot of improvements that we can make to this to-do app, this dummy app. We can improve the model itself to make better guesses or match the categories with the tasks better. We also need to be aware of the fact that it's not gonna be correct and it all the time. And as we saw, it can easily get answers wrong. So with a lot of these ML models, that's where this slide by Dan Saffer comes back, that the AI sweet spot is really where you can tolerate the model going wrong and still deliver usefulness. So it still took in Monopoly and chess and poker into the board games section, which reduced the user's work by a lot. Now they just needed to move the Mario game back to the video games section, which is just one click of a button away, versus them having to categorize each and every one of those, which would be a lot more work. So this feature reduced the user's work, and it did that without posing huge risks to the user when the model goes wrong. So yeah, but still, yeah, you definitely need to think about biases as well. Like this feature we haven't, it's just a demo app, so we haven't tested it for biases, but there will be bias like racial bias and so on, that could still be lurking around. But the underlying universal sentence encoder model is really in it has been tested for things like racial bias by the researchers who built it. In fact, in the research paper where they published their findings about the universal sentence encoder first, I think it came out in 2017. They showed all the metrics around, and they had a very rigorous way of testing it for things like racial bias and all that. So yeah, but it's always good to test your feature. Even though an underlying model has been tested for biases, the way you are using it for your feature could differ, and so you always should test your app. And there are some performance things that when you click the magic button, it kind of the app kind of freezes. You can improve it using React query, which is a library which we are using for the initial loading of the MediaPipe model, but we are not using it everywhere. But we should for any interaction that takes a while, like the categorization, because it has to do it for each task and it takes time. Yeah, so that's about it. Yeah, hope you had a good time, and wish you all happy new year. Forgot to mention that when we started. But yeah, that's all from my side today, and thank you so much for joining. If you have questions, I'll hang out for a while here, and if you have some time, would love to get feedback. I just shared the link in the chat. Yeah, so feel free to leave feedback. Looking to improve our community and yeah, bring awesome events to you.